Most of us have a laundry list of projects that we want to do around our home.
But making those improvements isn't always easy or inexpensive. So if you're going to make that investment, make sure it counts.
If you are careful and make smart choices to improve your home, you can save energy and lower your overall energy costs.
Today we'll show you some options that you might not have thought about that can also help you save energy.
And whether you're building or doing a retrofit can make your house a powerhouse.
PowerHouse, presented by Alliant Energy.
Alliant Energy, we're on for you.
At some point, it will be time to make choices in your house. Which heating system do I choose? Is it time for new windows and doors? And if you're building, the questions are endless.
Well, we're here today at a home under construction, and we'll be talking with the homeowner to find out what kind of options he selected to make this home more energy efficient and in the end save him money.
Join us is Dave Cushman. And Dave, I know you had several ideas in mind as you were building your home, many of which to save you energy and money. And talk a little bit about your goals with this house.
That's correct. Yeah, we've been working on this house design for over 5 years. We started off looking at the enclosure of the home and went with a SIP, structural insulated panel design that worked well with our timber frame. And then once we made that decision, we then wanted to have really high efficiency windows, and also looking at our foundation, we wanted to make sure that the bottom of our house was providing the same sort of energy efficiencies that our upstairs was. So we went with what's here called insulated concrete forms, and the principle behind these is you fill these with concrete and the form stays versus taking them off after the fact.
You got the insulation on the outside.
You got the insulation on the inside and the outside, so you have this thermal break with a high thermal mass in the middle. So it takes a long time for any sort of outside temperature changes to affect what's going on inside. But really what was the selling point for these was when you pour the concrete, there's this chemical reaction that goes on between the form and the concrete, and it creates this vapor barrier. So an ICF basement is much drier than a traditional poured basement. So the ICF just played off of the SIPs.
And the windows too, you selected windows that are very energy efficient.
Right, we went with, these are called H windows, which are a European design, and they're very tight, so there's very low air infiltration, but which was really nice. But really one of the top selling points is the action of the hardware for these. And as you can see, you can open and close them. Like there's a big variance of the window, but then if you want to wash it, you just pop that all the way out.
That's very cool.
How easy is that?
Flip it around and wash the outside of the window. So you're never working off ladders upstairs or anything.
And again, when you seal it up, you can just tell that it's a very nice tight seal there, Dave.
Right. The action, there's bolts that bolt in on the bottom and the top, so it gets a nice tight seal. Then you have this weather stripping that just pops in. So if you get damaged weather stripping, it's very easy to replace that.
Now I know that passive design was very important too.
Right.
As you were talking about this house.
In the northern hemisphere, we have a much lower track of the sun in the wintertime, and so we position the house facing south with the majority of the windows south, and we capture that sunlight, that winter sun as it comes in. What we did with this house is the main level here is a poured slab, and as you can see here, the sun's coming in, it's hitting the concrete, and that concrete's absorbing that heat, and as it absorbs that heat, it's essentially a heat sink, and then in the night, it's going to radiate that heat back out into the house.
And you've already seen that at work, right?
Right. We have right now the heat set at 55 degrees, and over the course of the day yesterday, we got up to 65 by capturing that sunlight, and this morning when we came in, it was 60 degrees, so we only lost 4 degrees overnight, and the heat never turned on.
Well, Dave, it's amazing. Meg and I are both smiling because you really have put a lot of thought into this. We got a model we can take a look at over here.
Yep.
Show us the non-traditional framing methods that you're using here.
That's correct. Yeah, we went with what's called a timber frame, which is really an old school way of building things. This is how buildings were built back in the 1800s and earlier. and it uses a technique called mortise and tendon joinery. So you can see here, a wooden peg joins two other pieces together, and that's it. So we don't have any screws or other fasteners.
It's great. Now, what kind of energy efficiency do you hope to see when the house is complete, your process is done? What are you hoping to gain?
Well, if I chop my own wood and use our wood boiler to heat the home, I'd probably be looking at about $40 a year in energy bills related to the heating.
40.
40. And if I went down the street and bought that wood, it would probably cost about $300 a year. And if we used the propane boiler, then we would be looking at in the $400 to $500 a year.
Incredible.
It really is.
This really is a wonderful house. I'm excited to look around and see the other elements that you've incorporated.
And if you're ready to get started saving energy, go online to get some ideas at our website at powerhousetv.com.
Which of the following is most important for a passive solar design? A, building site. B, climate. C, building materials. Or D, all of the above.
Alliant Energy, we're on for you.
The answer is D. According to energy.gov, passive solar design takes advantage of a building's site, climate, and materials to minimize energy use. Welcome back to PowerHouse. We've talked about ductless mini splits before. This is a heating and cooling system all in one, and oftentimes you'll see it used in applications like a room addition, or let's say a room is converted and traditional ductwork just can't go that far. Well, it's gaining more and more popularity in heating and cooling an entire home, and that's what we're looking at today. With us is Andrew Senti with Mitsubishi Electric. And Andrew, can you explain to us just kind of an overview of how this process works?
Yeah, it's actually a pretty simple system. We have a system that sits outdoors, and then what we're doing is we're feeding a set of refrigerant lines into the house. In an application like this, where we're having multiple indoor units, we'll actually feed we call a branch box up here, either in the ceiling or in the basement. From that branch box, we'll feed various indoor units like this.
Like this?
Yep, correct. And the beautiful thing, the way this system operates is, let's say we're in heating mode and you set this unit for 72 degrees. It's going to send that signal back through the branch box to the outdoor unit and say, hey, I need 72 degrees of heating. So that compressor in that outdoor unit is going to react just so it delivers just enough energy to maintain the 72 degree set point.
Okay. What are the advantages of having many units throughout a house compared to one central heating and cooling system? With
multiple indoor units scattered throughout the house, we can in turn have various set points throughout the house. So if they want it 68 degrees in this bedroom and his kids want it in 72 degrees, they have that flexibility, unlike most systems.
How much does a project like this cost?
It really depends on the application. A house like this could range anywhere from $8,000 to $30,000. But the industry estimate is a heat pump is about 40% more efficient than a natural gas furnace.
Great. Thank you so much, Andrew. This is great information.
Thank you.
The homeowner has another heating source in this house, and it's in-floor heating. Join us from Patterson Heating and Cooling is Brett Patterson. And Brett, let's try to simplify this for our viewers. What is in-floor heating?
In-floor heating is a source of heat that uses PEX tubing, similar to this here, that has water flowing throughout the house instead of large ductwork.
Okay, we're down in the lower level of the house here, and Brett, this I gotta say is pretty impressive as I look at this. Kind of walk us through what we're looking at here, and what does all this equipment mean?
Well, first off, we've got the heat source itself. It's a triangle tube, 95% efficient modulating boiler.
Okay.
That provides the heat for the whole system here. We've got a buffer tank here, which basically stores hot water at about 115 degrees. And we've got the distribution system here, our pumps, and our manifolds, and a couple different remote manifolds upstairs in this project as well.
Okay, so we look at the pumps here, and again, that's part of the zoned system, right, that
Yes,
comes with this?
yes.
And that's a real plus for in-floor heating, right?
Makes it very easy to zone a system.
Okay.
A normal duct system, you've got a lot of extra ductwork in the house, takes up a lot of space. With the in-floor heat, a lot of design flexibility for the end consumer because all the heat sources in the floor.
Okay, and I'm looking at the tubing here, and then up here I can see it in the up here in the floor, and this is the tubing goes in here, kind of help us out.
Yes, the Rahal rowel plate staples up or nails up to the subfloor underneath of it. The PEX tubing gets snapped into that there. This is an all aluminum plate, so it transfers the heat very well.
How warm, Brett, does this plate get?
About 100 degrees.
Okay.
And
All
that
right.
transfers to about 85 to 95 degree temperature on your floor upstairs.
And again, there's one of the benefits. It's a uniform heat across the rooms, right?
Yes, yep.
Okay. And that gets put up here, and explain as I pull this out for you.
Yes, yep. Once this is in place, stapled up to the subfloor, this foil insulation gets installed underneath it to help reflect that heat upstairs. So that radiant heat will be directed upstairs, not down here in the basement where we already have a heat source being the floor below
Okay.
us.
And you talk about the heat source in the floor. So the tubing here, we're in the lower level. You've got the tubing going in here, right?
Yes, yep. This tubing here is stapled to 2 inches of R10 foam insulation below the floor here to make this large mass a radiator.
Viewers on PowerHouse always interested in cost. What are we looking at in terms of cost for in-floor heating?
In-floor heating depends on the project itself. The average 1,500 square foot house with a boiler and in-floor heat in the whole basement runs about $15,000 to start with, and then kind of go up from there depending upon the project.
Okay. We may have viewers also out there looking in and say, geez, can I retrofit to my existing home? Is that a possibility?
Yes, it is. Ray Howe makes a couple different products that make that very easy. Ray Panel is a product that can be installed on top of your existing floor on the main floor of a house. Aluminum and plywood strips with the notches for the pegs to snap into. So it can be done. Better if it's done as part of a larger remodel project, but yes, it can be done.
Well, that's good to know. Again, well, Brett, I tell you, in-floor heating, a lot of neat things to learn about. And if you'd like to find out more about in-floor heating, go to our website at powerhousetv.com. True or false? Leaving a ceiling fan on in a room when you are not at home will cool the room.
Alliant Energy, we're on for you.
The answer is false. Fans cool people, not rooms. The air moving across your skin makes you feel cooler despite the temperature in the room. If you are not there to feel the benefit of the fan, then the fan is just moving air and wasting electricity. We're in a house that uses passive solar design solutions, using the heat from the sun to help warm the home. One of the key components of this system is the windows. And joining us from Zephyr Aluminum is Dan Zahn. And Dan, explain to us how the windows provide passive solar heat in a home.
Sure, Pete. We're using an H window from out of Ashland, Wisconsin. The passive solar heat idea is basically in the wintertime when the sun is low in the sky in the south, we bring that radiant heat through the glass and try to capture it into the home. And then the opposite is in effect in summertime when the sun is high in the sky, the house then shades the window, and when we don't want that radiant heat coming in through the window.
Now, these H windows use low E, right? Talk to us a little about what low E is.
Sure. Low emissivity is basically coatings that you can put on the interior surfaces of the insulated glass. And the low E basically in our climate in the Midwest keeps the heat out in the summer and it keeps the heat in the winter, which is something we, again, going to that radiant heat and trying to be energy efficient, we try to use. The low E in this house was put in on all three sides, east and west and north. And on the south side, we used one less coating of low E to try, again, capture that radiant heat from the sun just on the south.
You bet. Now, Dan, these are custom-made windows. Talk to us a little bit about everything that's going into make the H window.
Sure. The H window is a composite window. It is an extruded aluminum window at the exterior and a solid wood window at the interior, married together. The standard exterior surface finish is a powder coat. The homeowner in this project used a architectural grade 70% Kynar paint. He also then chose to have his interior wood painted in choice of his standard color from the factory.
And again, one thing that I noticed is that we were opening the windows and the sealant on those, very tight here on these windows.
Correct. The full perimeter of the window has a Q-lon, which is a nylon weather stripping in between the wood frame and the wood sash. So as the window is closed and drawn in, it closes very tightly against that weather strip.
Now, custom made, so we're talking a little bit more expensive for these windows, right?
Yeah, these are a little higher end window compared to some of our competitors. If you went to their high end window that they would offer, this window would be roughly 10-15% higher in cost.
Now, I know our homeowner though is hoping one-time purchase, right? The lifetime a lot longer for these.
Yes, there are. Because of the extruded aluminum framing at the exterior and the solid wood at the interior, this is once in a lifetime experience or purchase for the homeowner.
Dan, talk to us a little bit about the H window. More suitable for the climate here in the upper Midwest?
Sure, it's very durable. The big thing with this window too is it's very airtight. So we talk about the low E coatings and the U values of windows. This window is very airtight too, with that weather stripping. So in our climate, when we got a lot of wind in the wintertime, it is very tight. It keeps the cold air out.
And we like that here on PowerHouse. Dan, thanks a lot of great information. And if you'd like more information about windows, go to our website at powerhousetv.com.
True or false? U factor is the rate at which a window or door conducts non-solar heat flow.
Alliant Energy, we're on for you.
The answer is true. When looking for windows, be sure to look for the NFRC U factor, which represents the entire window's performance. Welcome back to PowerHouse. When building your house, there are lots of different options out there, especially when it comes to materials. This is Perry Penske, and he is with Extreme Panels, and you're going to tell us about structural insulated panels, which is what they've used here in this home. Explain to us what that is.
Structural insulated panels are expanded polystyrene in a sheet form that we glue to wood skins inside and out. These wood skins are oriented strand board, 7/16 OSB that is 8 foot by 24 foot in one piece. So we can make gigantic pieces. You're seeing just a small piece here. And this is actually a spline connection where the other panel would come onto it. And when
I see. And then this one would fit right.
Correct. We're
nested
caulking
right there.
all the way around. We're putting caulk here, 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 and here, and then the other panel adjoins to the next one. So envision that being an 8 foot wide panel, 24 foot long in one piece. That's how big these things can be. This hole right here is called an electrical chase, and we actually have them here right in the house where they're at this is at your switch height right here, and it goes continuous throughout the wall. And we have a vertical chase right here that goes from top to bottom. They're marked at the bottom of the panel. And then when you're simply done wiring this, you put the plug back in here, put some expandable foam in there, put the plug in, and it will be like you just never cut the hole.
So this foam sandwich, basically,
Yes.
it's not only the structure of the home, but it's also the insulation all in one. How does that affect the cost for the homeowner?
All in one, and that's the great point. The cost of this is a little bit different than your conventional studs getting delivered to the job site, your sheathing, vapor barrier, insulation. We have it all in one piece. And what that does is our cost of construction right up front is maybe a little different, but when we're done, we're going to have almost the same cost as your conventional stud framed house.
So it's pretty competitive then, and
It's
people
very
shouldn't rule it out
competitive.
because it's newer technology.
Correct. It's very competitive. Once the panels are erected in such a small amount of time, the labor savings to put this house up compared to your conventional stud framed house, it's a lot different. And that's, again, a big savings for the homeowner.
So it sounds to me like you make these customized for a house. So a house like this that has so many different angles and all of that stuff, you just pop it all together with these customized pieces. That must be pretty environmentally friendly then.
Yes, it's very environmentally friendly. And in this house, we have a lot of little pieces that are cut out of gigantic pieces. Well, in our factory, we will actually take that waste, and we have great methods to get rid of it that don't go into the landfill. And it's a huge reason why when you get panels delivered to the job site, you don't need a dumpster until after the panels are up.
Well, here in the Midwest, our value is very important to us with these extreme temperatures. Let's talk about our value.
Our value in this 6.5-inch wall, it is about an R26. And the thing about the solid foam core is you do not have studs in the wall. And every 16 inches, when you don't have that loss of R value, it makes a huge difference on the whole wall and how the whole assembly performs. So when you're actually looking at a whole wall and testing it, you are getting a full R26 out of this wall instead of the normal stud wall that has an R19 bad in it with studs every 16 inch on center. You can get down to an R8 to 10 or 11.
That's a really good point. Or the insulation too, would kind of hold some cold air in there, and so that would be modified. But
Sure.
this is going nowhere, and this is always going to retain that R value.
Correct. And the neat thing about a structural insulated panel is the symmetry of the system. It doesn't care if it's cold out or hot out on the outside skin. When we build in the Midwest, we build for the heating season. So we always put our vapor barrier on the inside. Well, in the summer months when we are cooling, we're actually built wrong. But the benefit of the SIP panel is it doesn't care what time of the year it is. It performs better in the hot and the cold, and it just performs great. Last week I just had a customer call that said she was actually crying, and normally that's not a good sign, but in this case the end was a good outcome. Her January heat bill for her house was $39. Her previous home that she lived in, it was over $300 in January. We saved her $300 a month in her heating bill.
Well, that's a great story. Good to know there are lots of options out there if you're building a new home.
Megan, what a fascinating show today.
I really love this house.
We had the opportunity to see how one homeowner built energy efficiency into their home.
And Dave used a passive solar design to take full advantage of the sun, and high-efficiency windows made that possible.
And with the ductless mini split system, he can heat or cool several rooms in his house, taking a zone system to a whole new level.
And structural insulated panels is a great way to build a tight and solid home. It all adds up to another way to make your house a powerhouse.
Megan's wardrobe provided by Dress Barn.